Sorry, I had some challenge, but I'm now back. Now I can see Joanne, you are the host. After I left because of the network, you automatically became the host. So you can press record so that we can start.
Still recording something.
Oh, it's recording, eh? Oh yes, I can see that. Thank you.
Yes.
Thank you. Okay, so let's start. I hope you've all cloned the repository that I had asked you clone, because along the way we'll be doing it practically so that we move together. That is how I want us to move, so that as we progress, I'll be using yours because mine I've already installed. So what we will want is that as we progress, we will then install our Circom and then proceed with it. I don't know whether you can see what I'm projecting. Can you see?
Yes, we can see.
Okay. So we'll begin looking at some languages that I used to write zero knowledge proofs. And this is the first language you'll be looking at. We've done so a lot that that means at this point we are ready to write the zero knowledge proofs going forward. What we've done is enough to enable us to do that. For instance, last week and the other one, we were looking at the arithmetic circuits, and we also looked at the rank 1 constraint systems. So the way we wrote the rank 1 constraint systems is the same way we're writing this Circom language. So it's just the same thing. This is the easiest language to write. Once you come up with the questions, just write them directly, the way we were doing last time. Now, I've said that unlike the high-level languages that abstract away complexity, Circom gives you precise low-level control over your circuit. Now, what I mean by low-level control over your circuit is that, for instance, if you know the equation that y is equals to, let me say, x squared. Let me just say x squared, even times what times, let me say z. Supposing we know the equation is z is x squared multiplied by y, we'll just be doing what we did last time. What we did last time is that we call x squared to be v, and then we say that z therefore becomes v1 times y. So that at the end of writing our equation, the final equation has only one product. Unlike in this case, the products were, we had x multiplied by x and then multiplied by y. Those are three products. But what we said, when you're writing the rank 1 constraint system, everything we are doing is that we want to have our equation have only one product. And so that is what we come up with. So when we come to this language, when I say it gives you low-level control over your circuit, what I mean is it enables you to write the equations the way they are. Just write them the way they are. Unlike the high-level languages, when I say high-level language and low-level language, I don't mean that one language is superior over the other. The word level here, it's just used to mean that one language gives you the ability to take control of what you are writing. And the other language does not give you that ability. So that the other language, what it does is that you would define a few terminology, a few things there, then whatever, and then it takes over from there, for instance. So you will not have that full control over what. So I'll show you the difference in a short while. For instance, if I have this equation and I'm using the Circom language, it's me to write this equation. It's me to write this equation. Then I tell it to give me the output. Give me the output for Z. So I'm telling it what I want to do. So then that is what they refer to as low-level control, low-level control. And this other one is high-level. It means that it doesn't mean that it's superior. It just means that this other language will not give you control over what you are doing. So you may define a few things and then it takes over from there. Now, so this language, Circom, is a very powerful tool in writing zero-knowledge proofs. It's very powerful, just like the other languages. So that is the point I wanted to clarify, the issue of the high level and the issue of the low level, so that you don't take it that one language is superior over the other. They are all as important. And of course, the cases where this language becomes with the several advantages. What I mean is that there are cases where this language becomes the one that should be used. There are cases where it is the one that you must use. Now, so that is the only point I wanted to clarify on this first slide. There's a note here. I've said that as far as these notes are concerned, what we are doing, we shall be assuming that what we'll be using would be Circom 2.1 plus. So that means what we'll be using will be the most current. Of course, if you did a clone from that GitHub, what you got was the most current. So that is what we will then be using. So what I've done is that, okay, so this is what I've been talking about. So when do we use Circom? When is it used? I've highlighted a few areas where it is suitable. A few areas where this language is suitable. One, for learning how ZK circuits work under the hood. And the reason I've already explained is that this language will assist us to learn how ZK circuits work because one, it gives us control to write the circuits. So it's us who will be writing those circuits. So as we write, of course, as we do that, we then understand how ZK works. So that is so that you're not just doing something, you don't know how it works. For us, we know. So for instance, we know that if you have this equation, we want to write, somebody wants to, for instance, let's say somebody wants to claim that he knows what Z is here. Then we write this circuit. This is a circuit. We will write it in Circom and then verify whether the witness the guy will be giving us will be correct. Of course, we talked about witness, and we will again be seeing how to write this witness. So that is one advantage. It's giving us ability to understand how ZK works. And this, I've said, it will help us to demystify how high-level operations decompose into low-level constraints, so that we don't see things, maybe ZK to be very hard things. We'll be seeing how you can write even high-level ZK equations. This is the other way, the other place we can use it in prototyping small ZK modules. And then we have also do it for gaining precise control over constraint generation. And this is almost similar to the first point I had already talked about. Now, so I've already stated that this language gives us control over the circuits. So that then that comes with a disadvantage. The disadvantage is that because it's you that is taking control, if you are to mess, then it means the whole thing will be a mess. The whole thing will be a problem. So that means you must be very keen when you are doing that, when you are writing using this language. So that is the only disadvantage, because it's you who is taking control over the ZK that you're writing. Because it's you will input all this, the equations, all the signals. It's you will be putting all of them, so they must be correctly put. Now, the example, for instance, we talked about this. We had when we were looking at the R1CS, the rank 1 constraint system. We talked about this. This is already in the format rank 1 constraint system, so we do not need to have intermediate values. So this one, you just write it the way it is. This is how you write it in Circom. This is how you write it. You have the input X. The inputs, we call them signal input. So signal input X, and then signal input Y. And then we have now the output, which we call the signal output. signal output. So just write this, and then you tell it that I want this output to be a product of these two. So then you just write this. So this is what you do. This is what you do if you're writing the Circom language. If you wanted to generate, let me say, witness for this, you wanted to generate witness for this, you wanted to verify those witnesses for this, and somebody claimed to know what Z was, this is enough. This is what you enter into your code. This is your code, complete code. This is your complete code. So just tell it signal input X, signal input Y, then signal output Z. Then you tell it, I want Z to be a product of these two. And then we will run this. When you run this, you may choose to run that you want witness, or you want to verify the witness given, and so on. So, but we'll be seeing how to run, so that when you run, you want to know whether the witness is correct. There's a way you'll be running that, and we'll be learning all those. So you can see it's very easy using this language, so long as you know what the circuit is, and you know how to write the rank 1 constraint systems as we had discussed earlier. But for this one is already in the format of rank 1 constraint system. Rank 1 constraint system, I just repeat, we said you ensure that there's only one multiplication. And so for this case, you already have only one multiplication. So once you have only one multiplication, you just enter the inputs. Enter the inputs and then enter the output. Then tell it that this output should be X multiplied by Z. This is why we say this is a low-level language. So by low-level language, again, I repeat, we don't mean that it's a language that is inferior. We just mean that it allows you to take control of what you are writing. Now, supposing I was to use a different language, and this is NOR. There are several languages for writing zero-knowledge proof. NOR is another one. Now, if it were NOR, I will not write it the way NOR. I would do it this way, the way you normally do it in Rust. Function, main, and so X, field, Y, field, and then it should return this, and so on. So, but now, when you do this, the other things, NOR will take care of that. So you need to define the main, and okay, this is not complete, but of course, this is how we'll be proceeding when we begin looking at this other language, NOR. So you can see they are different. Like the Circom is just direct, just telling it, the input is this, the other input is this, and then the output will be this. Then this output should be arrived at by this times this. And you run it and gives you that. It gives you the result. So they're slightly different, but this other one, I find it to be easier. The first one, Circom, I find it to be easier. So the NOR and the other higher level languages, after you've given them the code, they'll automatically handle the underlying constraint generation. They'll do that. But this other one, it gives you the mandate to handle everything, so that everything that is happening, it's you doing it, making it happen. And so because of that is why I've given a warning here when you're using Circom. I've said, because you are the one taking care of everything, you must ensure that after you've written your audit, after writing your contract, ensure that there is a professional audit, just to ensure that, go through again and see that whatever you've written is correct before you deploy it. Because since it had given you the mandate to take control of everything, there might have risen some human error in so doing. So you need just somebody to verify that the contract has been correctly written. Now, so if you wanted to use for example, you want higher languages, of course, these are some of them. And we'll be looking at some of, we may, after looking at Circom, we'll want to look at NOR and then look at Leo and so on, so that we are familiar with how these languages are used to write zero knowledge proofs. Now, so that was just introduction. Now we want to begin looking at how to install our dependencies in Circom. And I think you have cloned it. So we'll just be using somebody's. We can begin by Joan. Joan, you have yours? Is yours ready? So because for me,
Yes.
I've already. You have?
Yeah, I have already cloned it.
Okay, because mine I've already installed. So
Mm-hmm.
we want to use somebody who has not installed, so that we install together as others follow. So we'll then be just installing it together. But let's just go through steps first of all before we.
Yeah, you want
I'll give you an opportunity to share once we've gone through the steps. You will share so that then we follow the steps together as we install the dependencies.
okay.
Yes. Now, so to install, of course, for you to have it run, you require the following. You require Rust, which we already have. We've already installed, we have Rust, we've been using that. That is one thing that we require. We require Rust because the compiler of Circom uses Rust, is written in Rust. So that is why we require it. Then we will, after that, then we will need to now install the node.js and then the PM, the package manager. It's abbreviated by NPM, the node and P package manager. So this is what we shall then install. But for us, we already have Rust. So what we only need to install is this. So we'll be going through the steps of installing it so that we can now begin writing using this language. Now, so these are just the steps of installing Rust, but we already have it. So we can skip that. And then we come to now what we need to install. And that is the NPM and node and the package manager. Now, so we've already, so what we've been installing, of course, will be version 10 and above, because we've cloned from the right GitHub. So these are just the steps. This is the link that I gave you to use for cloning. That was the link. Now, so what we will do, we'll now do is that Joan will now open the Rust and then CD Circom. I don't know, how have you stored it, Joan?
Yeah, I've just studied as Circom. I think someone else should share their screen because I think I've installed like literally everything that you've already said I should install there.
Or you've already installed, huh?
Yeah, I have Road, I have Last, I have everything there. Yeah.
Oh, so we can use, whom can we use? If
Hey,
Have you installed yours?
yes, I have installed almost up to the cargo build release.
Up
So
to?
like okay, I'm using my phone. I
Okay,
don't
okay.
know if I can share my screen from my laptop.
You're using your phone?
Yeah.
No, is your knee is not on your phone. Your Rust
No,
code is not Rust is
yeah,
not on your
of course
phone.
it's not on my phone, but I can try and join the meeting via my laptop.
No, but what about who is using laptop? Chris. There's Chris. There's Del Rock. We have Kabute and somebody else, Bahati. Anybody using laptop and has not installed these the dependencies so that we can move together? Or maybe I can just use mine. Then as we progress, I think people can just follow later on. Now, so what happens is, let me just share my code, my Rust. Now, for me, I've installed all of them. That is why you can see several of them on my left side here. Most of them on my left side. There are so many things here I've installed. So every time you install, they add themselves here on your left side. Now, so what we were to do, I'd said that, okay, this is where I store my Rust codes. This is in Rust. So to reach here, to reach to Circom master is just the same way we normally do. Code Circom master. That's how I've stored it. I've stored it as Circom master. So what then are we supposed to do is I decided we CD Circom. After reaching here, you just CD Circom so that you are inside that. And now, so we are doing this so that now we can create, okay, in fact, whatever code we want to create, we'll be creating it inside this Circom. So that is why I have to CD it. So of course, we will open a file here. And after opening a file there, we'll have to store our code there. But we will arrive at that. So after CD, after doing CD Circom, we will then compile the project in a release mode. You just say cargo build, release, cargo build, release. So why is that? That is just to ensure that we produce a binary at the target release Circom. So just to release, to produce that binary. But that process, if for those who have not done it and are following, just write here. After CD Circom, you just write cargo build release and then press enter. That process takes about 3 to 5 minutes. Let me just see whether mine can do it because I had already done it. I don't know whether doing it again would cause some problems. I had already done this. So you just say, okay, I had already done it so that it cannot even run now. It cannot give me that option. But if you have not done it, you just, after CD Circom, you just say cargo build and then some space, then this dash release. Anybody doing that? But that is a step. That's the first step you would then do. For us to install the dependencies, that is the first step. And then the next step, you would say cargo install patch Circom. Cargo install. So that is what I want to write. So after that, so this one will just enable you to be in a position that every time you invoke Circom from, it can always run and give you the results you want. Okay, somebody has written something on the chat, but I have not understood. I don't know whether. Oh, okay. So he's saying about mine. Eh? Is it mine or yours? The person who is chatting here, make sure you have Rust. Somebody. Okay, somebody's Delcom says cargo build command is not recognized. So which command did you put?
Hello, can you hear me?
Yes. Yes.
Sorry for interruption. I'm Delron.
Yes.
So I used the cargo build dash release, the one that you have told us to run on the command line. But I'm getting the error that the term cargo is not recognized. You know, when you have not installed maybe a particular library or related libraries for that particular code that you're running. So I don't know how to go about it. Since I'm still new to this.
Okay.
Yeah.
Do you have Rust? Somebody has said you should have Rust.
Okay, I have not yet installed Rust.
Yeah, you must begin by. I began by assuming that we all have Rust.
Okay, no problem. Then I'll install that.
Yes, you should have Rust first of all, because what we are doing is the compiler depends on Rust. So that I think that is where the problem is.
No problem. Thank you.
Yes, you need to have Rust first of all. Okay, another person doing it with us. So I'd say to ensure that every time you use command Circom, you will always get good results. You need to install cargo install. So you use cargo install path Circom. So we are done as cargo build release, and we got you got some results after pressing enter. So the next thing you will do is cargo install dash path Circom. So that is what you would then. This is what you now enter. Press enter. So that is how you install that. Now, so that one will now will assist to install a binary into home. And that also ensures that the directories on your system's path. So that is what it ensures. That is why that command is very important. Now, so if you have done that, then you should be seeing some changes on your left side. Should be seeing some things, I think, on the left side adding themselves there. Some names coming up which were not there, if you have done correctly up to that point. Now, for you to be sure that you've done correct installation, after just what you've done, the next thing you want to know whether the installation has been done, you can do command Circom help. You do Circom help. So you enter Circom help, then press enter. Then if your installation was correct, after when you enter Circom help, it will bring you the Circom compiler. It will bring you Circom compiler. So let me just try mine and see whether, because that one, I can enter that. Just a minute. Input file does not. Oh, I had gone out of CD Circom, so that is why I have this. I had gone out of that because I must be inside there first of all, then say Circom help. Just a minute. I don't know whether it does not allow somebody to do it twice or what. Because I had already done this process. Input file does not exist. Help. Previous errors are found. Okay, so maybe I may want just to go through the whole process also. But that's why I wanted us to move with somebody who has not done the installation so that we move together step by step. But now let me just share the notes of what the compiler looks like after you enter Circom help. What you get, just want to share what you get. So when you enter Circom help, this is what you get. It's just telling us what we're doing. So I enter Circom help and I get this. This is what you then get. These are the things you get. It tells you that you have the rank 1 constant system is one of the flags. So at one point, when we do Circom, then dash rank 1 constant system, this is what that command will be giving us. We're outputting the constraints in the rank 1 format. It outputs the constraints in the rank 1 format. Now, if you do a Circom and then dash simp, then it outputs the witness in the simp format. It outputs the witness in the simp format. But now when you tell it Circom dash and then WASM, it compiles the circuit to WASM. So that's what it's saying. That is what you get when you say Circom when you run this. Now, somebody says cargo build release is supposed to take about 3 to 5 minutes, approximately 3 to 5 minutes. So you'll be seeing something up chin, you see something like So how is it hapo chini? Kuna kakitu kana gonga. This is Chris. Chris, how long did your cargo build release take? Is it still, because it's supposed to take approximately not more than 5 minutes. Now, so we're looking at this, what you get when you say Circom help. These are what you get. So you'll just go through this. They are not the only ones. We also have, they come up to here. So if you do Circom help, this is what you're supposed to get. So these are some of the commands we'll just be using. These are what is on the left, the flags. These are the commands sometimes we'll be using. And what we'll be getting is what is on the right-hand side. When you use that command, whatever is on the right-hand side is what you'll then be getting. Now, so that means we've now installed the dependencies. So what we then install is the snacks. What we then install is the snacks. Okay, so let me just go back to okay, to install the snacks, you input. This is what you input. And then press enter. npm install, then -G, then some space, snacks at latest. Snacks at latest. Even without at latest, you still install those snacks. But at latest means now you're getting the latest version. That's what it means. Now, so why are we installing this? We're installing this just to facilitate working with the zero knowledge proofs. This is what will helping us to work with the zero knowledge proofs. So it will then assist us to be in a position to perform tasks such as trusted setup, ceremonies, proof generation, and verification. So if you want to do that, if you want to do trusted setup ceremonies, you want to do proofs generation, you want to do verification, and this is what we do in zero knowledge proofs. You have to install the snacks, the snack.js. Now, anybody who is stuck so that we move, because having installed the snacks, we are ready now to begin writing our zero knowledge proofs, because that is the last thing we install. After installing that, we are ready to begin writing. Joy, is it Joanne, had you installed the snacks?
Not exactly. I'm actually installing the cargo install path, the path for the Circom. Yeah.
Or which command are you using now? The cargo build release?
No, the cargo.
Cargo install path.
Yeah.
Install path.
Yeah, that's the one I'm
Okay,
using.
so when you did cargo build release, did it take long?
Yeah, it has taken some while, like
Mm.
10 minutes. I think it's
Oh,
because I'm also
okay.
in the network, yeah. Because you're also in, like, we're using the network, so
Oh,
that's
I
why it's
think
kind of
that could be. So, oh, it's so okay. So maybe that is the reason. Eh? Now,
yeah,
can you
yeah.
share your?
Can I share my
Can you
screen?
can you share yours?
Okay, let me share my. I'll just okay. I am using the terminal to install, so I'm not sure whether I should share both. Let me just share
Oh,
the whole screen. Can you see my screen?
yeah, it has started sharing. It came, but I
Yeah,
think it's about.
so right now, can you see it?
Yeah, you can now see it.
Yeah, and now I am doing the cargo install at Circom. It's the one installing
Mhm.
right now. It's taking
Mhm.
time. Yeah, it's taking time on my side.
Okay.
But I think it's because the way we are in both the session and also like installing at the same time. It's taking a bit of time.
Where is your terminal?
Here's my terminal. Can you see it?
At the top. Or
Okay,
the one
here's
I'm seeing
my
at the top.
terminal. Can you see my screen?
Yes, I can see it. You've minimized.
So yeah, here's the terminal.
Yes, I
Yeah,
can
I've
see it.
minimized it. I should maximize it.
No, no, no. We can see because what I was looking for
Uh-huh.
was the terminal.
Mhm.
So, oh, I can see it saying building.
Yeah, it's still building.
Okay, okay.
That is for the cargo install pathway. Yeah.
Yours is a bit different from mine.
Oh, I am
The way I
using a
wrote it.
different software.
Okay, okay.
Pardon?
I can see it saying 61 out of 172.
Yeah,
Is it? Yeah, so it means it
yeah,
has
yeah,
is now at 66 and so on, 69. Okay, so maybe we can just continue.
yeah.
Then after it's done,
Yeah.
you tell us
Okay.
so you can unshare. Yes, you can unshare. There's somebody said the cargo is this. Somebody says laptop struggling with Windows and I should probably install Ubuntu. Yeah, you see, the problem I don't know the Rust that I use I was installed for. I don't know. There is normal Ubuntu, I think, somewhere. Or is it W? I don't understand. I'm not very familiar with these terminologies. I was installed for the Rust that I use. But I think there was some Ubuntu or was W SL. I know you guys understand this terminology well. So Chris, you are struggling. So it means after you've installed whatever you require, do you normally use Rust, Chris? Okay, Chris says he uses Rust. So if you normally use Rust, where's the problem? When you which command is that is making it, or it has finished building? So what command are you done with? Cargo build release. Oh, it took some time. That is okay. Now, so if you are done with cargo build release, that means you're on the right track. So the next thing you're supposed to do is cargo install path. Cargo install path Circom. Let me just put it in the chat so that you follow it. So if you are done with cargo release, now you can enter that cargo install dot dash dash path. Remember, recall that dash dash should be far from install, but it should be attached to path. Should be attached. There should be no space. There should be no space between the last dash and the P. So it's just a single word, but there's a space between install and the first dash. Not a very big, just one spacing. You can just copy what I've put here. You can copy what I put there and then use that. Now, after that one is done, you can now see whether you've done the right installation. If the installation has been perfectly done, and for you to see whether it's perfectly done, you will have to do Circom help. Circom help. And so when you do Circom help, you are then in a position to see what I had shared previously. You're able to see this. So when you see this, all this, you see all this. So when you see all of this, then it means your installation has been perfectly done. Now, so what follows from there is you then need to install the Snacks JS. The Snacks JS, and again, let me type it in the chat so that you have you follow that. So after this, the help, and after you seeing that everything is okay, you then type, you enter this. This is the command now. npm install, there's a spacing, then a -g, then spacing snacks JS at latest. John, I think you are now at the point of the snacks, is it? They did finish
Or
building?
it's taking time about that. No, it was finished building, but they're installing it at 163, so it's a bit slow.
Oh, still installing, eh?
Yeah.
Okay. Yeah, just give it time. What about if you are using a phone?
Okay, I'm still installing them. I still have my laptop.
At what point are you?
I'm still at the building parts. I did not have Rust, so I had to install both.
Oh, okay, okay, okay.
Yeah.
Okay. Del Rock, yours, what did we say? You had said you would, first of all, install Rust, huh?
Yes, I've installed. Now, when I'm running
Yes.
this command cargo build,
Mm.
please. So I'm getting that blocking. Okay, now compiling. It's now it's at other places combining, others getting error. Could not combine quote, like some other things are not being compiled. I don't know why.
Yeah, there are
It has
steps in
completed.
that in installing Rust. Huh?
Yes.
There are some steps. I don't know whether you followed the right steps of installing Rust, because it also
Yeah.
has some steps of you.
Yeah, I followed the right steps.
Mm.
I've read the Rust manual while installing.
Okay. Mm. Okay, maybe that one look at it late. What about Swiga Bahati? At what point are you? Now, what could be the issue with the Rust of Del Ronc? What would be the issue? You said your Rust is well done. Okay, let's just see whether your Rust is well done. Let's just want to send you a small code and then you run it. You see whether your Rust is well done. Del Rock,
Yes, I'm
try
here.
your Rust. Try your Rust with this code and then do cargo run. You see whether it runs.
Okay. So how should I name the path of the file when trying to test that? Like,
Uh, when you're trying to, do you have any? What you do?
yes,
You just is it cargo code or something? How do you normally do that? When you want to come up with a new thing,
a new
is
file
cargo
of
new?
oh,
You say cargo new.
go new.
Then when you enter, it opens you somewhere. You enter this code.
Okay. Let me see.
I hope you are outside the
I
Circom.
had to
You
put
are
a path.
outside.
If I'm
Uh-huh.
outside Circom.
Uh, yes, this will be outside Circom because we want to test your Rust.
Okay.
Mm.
Okay, I'm being told that the following arguments were not provided. That is the path. It should have cargo, new, then path.
Yes, it's cargo new, then the name. Just give it any name.
Okay.
Cargo new, then space. Then after
Yes.
space, just say a Tryon. That any name, just give it any name.
Okay, it's creating. It's
Okay, you can share it. Well, let's see.
I can share my screen, yeah?
Just share your screen.
Okay, no pressure. Okay, can you see it? Can you see my screen?
Yes, yes, I can see it.
Okay, so I've created here the file. Here it is, trial. So I have to go to cargo.tom. We have this part. So here is the command that we have been working on. Here. Main.rust, yeah? Here it is.
Yes.
Let me run it and see.
Run it, see whether it runs.
Error linker.exe not found.
So it's not
So
running.
yeah. So I can see the error is that I have to install Visual C, the Visual Studio for C that has the built-in tools. Yeah, okay, no problem. Let me do it as fast.
Yeah, that's where the problem is.
Okay, no pressure. Let me do it as fast as possible.
It's okay. Okay, you can unshare again. Now, okay, let's again see. John, how far are you?
I have managed to finish to install it. I've managed to finish the installations.
Okay, what part have you finished?
I've finished
What?
I've finished the snacks right now. Let me just share my screen and allow. Wait, let me just share the terminal for now. Share. Can you see my screen right now? Can you hear me? Can anyone hear me?
Yeah, we're hearing you.
Okay, so I have just, this was just a simple error because I had not written the sudo command. But yeah, I have managed to finish it's big. I managed to finish the cargo install path for the Circom, and it has finished installing, and I've done cargo help, and I've got the output as it was in the screen. So I'm back. Was like and it gave us the same output as it was in the screen. Then after that, I did npm install for the snacks. That is, we are using Ubuntu. Just make sure you write it sudo to avoid permission errors, and it installed. So yeah.
Yeah, Joan, you were saying something before my network disrupted me.
Oh, I am sorry for that. I was like, I have finished to uninstall. Let me just share again my screen.
Okay.
Let me share my terminal. Yeah, you can see my terminal right now, right?
Still coming. Not yet. Just about. Yeah, I can now see. Yes.
Okay, so you can see it. So I have finished installing the cargo and for the pathway, and it was done. Then I did the Circom help, and I got the output as you shown us in the screen.
Yeah. I can see it here. This is the output.
Then after this is the output that I got.
Yes.
For the help, then I did for the npm install snacks. At first, I did get an error because I was not using permissions, but when I included permissions, it was successful. The snacks were installed successful. Yeah.
Okay. That is so after we've installed the snacks, then the next thing you want to verify whether the snacks have been if they have been installed. For you to verify that, you do node, then space, and then -v. Let me just share. Let me just send that in our chat. So you want to verify whether the snacks have been correctly installed. You would then do node, then space, then -v. Just do that. What does it say down there? It gives you the version. Gives you the version that has been installed. Is that okay? And then you also put npm dash. There's a space and then -v. Again, it's supposed to give you the version of the npm. So the first one that you see there is the version of the node. The version of the node is saying the version 20.19.0. Then the version of the npm, it's now 10.8.2. So that now means that you've installed your snacks correctly. So because now we're getting the versions of the installation. So that is the only thing you need to verify. Now, so again, the other thing we can do, you want to check whether everything is working. You say snack.js, then some space, then -help. Want to ensure that everything is working. So let me just see. Say snacks, okay. What does it bring? So it's snack.js. That is what it comes. Is that okay? Yes, so that tells you that everything is working, because you can see just above there, there's written there type of snacks. Then there's a command, then there is a help to get. Now, so for instance, the snacks you see there, for instance, the first one is power. Is it PowerSoft? Now, there are all of them, even including, all of them are there. Just scroll down. Can you say something like growth 16? Long growth 16, verify. Those are the types of the snacks that all of them are there. You can, I can see verify there. You can see, what is growth 16? Yes, growth 16, the one you are pointing at. Now you can see what growth 16 will be doing. Growth 16 setup, it says creates an initial growth 16 P key file with 0 contributions. So all the snacks are there, and they're what they'll be doing. What they'll be doing is on the right side. So that means everything is working for this. All the snacks have been installed, and therefore you are ready to begin writing. Okay, so let's again see where our colleagues are so that we move together. We want to ensure that everyone has the snacks installed and ready for writing the zero knowledge proofs. So okay, so Chris, how far again? Chris, you are installing something, or was it Del Norung who was installing something?
Yeah, I'm on it. Just in the next few seconds, it will be done.
You were installing what?
I'm installing. I've just changed. I'm not using now Windows since I don't want to install Microsoft on Windows. I want to install on Kali Linux. I'm working on Kali Linux right now.
It's okay.
Just in the next few, it will be
And
okay.
then okay, then Chris. If you are doing something, you had said there's something you are working on.
Yeah. Okay, my laptop is quite slow, but I'm installing. Okay, I'm installing the part. I'm still at the part.
Oh, that is you are on a cargo install path Circom.
Yeah.
The cargo build release was complete. Is that okay?
Yeah.
Oh, so you're about there. So once you are done with that, you'll do Circom help, and then we see what you then get. Want to say that we are all at the snacks. Once we all install the snacks and everything is okay, we will then begin writing the circuits and see how to run. Okay, so John, you had gone, you had already finished, you had done the snacks help, and you have a reply. Now, we want now to create, we want to write something, and before that, we create a file. I want us to, inside Circom, Joan, can you share yours? Are you still sharing?
Oh, okay, let me share again.
Okay. Because we want now to create, want to try and write something. The example we looked at.
I have just shared the whole screen. Okay.
Okay.
We are creating in the VS Code, right? Can you hear me?
Oh, yes, I can hear you. Are
We
you
are creating in
still
the VS Code.
inside that Circom?
Okay.
Below
Yes, I'm
that,
still. Yeah, I'm still in the Circom.
okay. I can't see your left side of. I was looking at that left side where there's GitHub and then.
Oh, the BS code.
Yeah. Yes. Now you can see there's that GitHub. Then there's this Circom. Is that okay?
Yeah.
Click on it.
Pardon?
Click on the word Circom. Okay. Now you can see this up there. We have some rectangle with a plus. Point on the first one. You see what it is. Point on the first one. It says new file. Click on that so that the new file comes just under that. Yes. Now that new file, I want you to name it multiply.circom. Multiply.circom. That is why we want now to create our code. Good. Now it has opened there. Now, so every time you want to make a new code, you'll be creating a file and then you write your code there. So the code I want you to write, I'll just send you the code and then you copy and then paste there.
Okay.
So that we can save on time. The code is in the chat. Chris has a question. Chris is asking why he can only see the Circom. We have other. You see what we are getting is from what you had cloned some the Circom. Is that Chris? Chris. Okay, so this is code. The code I shared. Is that is true? Now, what is happening, John?
Should it be
I'm
this
saying.
way?
No,
Should
I
it be
think
arranged this way? It's
no, it's just supposed to be arranged correctly. Just delete on the left, move it to the left. The way you would just you would write the code. Just move it. It's because of as I did it paste. When you copy and then it is that's how it comes out.
okay. Is it making
Now,
sense
so
now?
this this arrow should be pointing to out. This arrow should be pointing to out.
Okay.
You're seeing where the arrow is, so out should be on the left side of.
That way.
Yes. Now, so what we are saying is, what we wanted, what we had is the first code I'd given A times B gives us Z. So in that case, A is an input, B is an input, but Z is an output.
Yeah.
So that's what we just typed. I'm not seeing. Okay, I can now see. Now look what the last bit. The last bit of that code. Okay, just a minute. Let me see. Okay, so let me again see. Now, so what I was saying, the last bit has, not seeing it on your knee. Where we have multiply, something multiply. It's like, have you deleted something after this output? What is the next line? Where's the next line? The next line that is supposed to read component main equals to multiply.
Is it?
Yes,
Can you see it right now?
I can see it. Now, this multiply is what we call our file. Our file was called multiply.circom. Is that okay?
Yes.
So this multiply is what is there. So if you change the name of no, there's no problem. If you change the name, then this one you must also change. You must also change the last word. This is multiply and then 2 brackets. Now, so after writing that, you write your code. So your code is saved like that. So that's the first thing you do. You write the code. After writing the code, and now the explanation, I've already said the explanation. You have the signal input, that one tells you the first input, then there's a second input, then there's the output. Then we've saved it as multiply.circom. Of course, we will be saving our codes in different names depending on what you want to do. Now to compile this, you do circom space multiply.circom.
On the terminal.
Yes. But you must be in Circom. Let me see, look at yours. You remember we've done CD Circom?
Yeah. I mean, Circom already. Let me rename here so that we don't get errors.
Rename what?
Okay, I was renaming that file, had written some errors. So you have said reads
we had already
to run it.
Okay, to run that, you do Circom space multiply.circom.
Okay, hope it's going to.
It has said the input file does not
exist. Multiply.
No, you see, you see when we began, we should have said CD Circom first of all, so that we are inside the Circom. CD Circom, enter, so that we see what you get. Then after CD, now write what I've just said. Circom space multiply dot Circom. Yes, it says template instance 1, everything went okay.
Okay.
Yeah, so everything is okay. Now that we move the next step. The next step is now to generate the rank 1 constraints. To generate the rank 1 constraint system and the symbol files. So for you to do that, for you now to generate that, you see what we've just done, we just run the code. And when you run the code, you don't say anything. You don't say what you only see what is what you've got, what you've seen there. What says template instance is 1 and everything went okay. But there's an output. So now to see the output, you would now want to run use the command Circom space multiply dot Circom, and then space dash dash R1CS.
In capitals, or it should be in small?
In small, R1CS, then some space, dash dash sim, dash dash
Pardon?
sim. That is dash dash, then SYM, dash dash SYM. Okay, you can enter that. Now there's something there. It says, and template instances 1. It says we have nonlinear constraints, we have linear constraints, and so on. But down there it says it has successfully written multiply dot rank 1 constraints. Then has also, it has disappeared, John. I can't see it. Okay.
Sorry.
It has also successfully written. Yes, I can now see it. But when you look at your left side, there's some folders which have now added. We had the GitHub and then Circom. Then below there you can see multiply. The first one is the one you're pointing at is multiply what? Circom. That is the name of the folder. Then below it we have multiply rank 1 constraint. And then we also have multiply sim. So some folders have added. Now, so the rank 1 constraint system, those constraints have been now generated, but you cannot see them. For you to see them, you have to again do another command. But the thing is, they have now been rank 1 constraint systems have been generated in binary form. You cannot see them, but for you to see them now, you write snack.js, then space R1CS, there's just space, and then R1CS, then some space, print, then space, multiply, the space, multiply dot R1CS, multiply dot R1CS. Now it will now print for you what it has written in the rank 1 constraint system. It will now print. So the first thing we did, it generated. Now when you press enter, it prints. Now what it has printed is mod P. Now the P, this number begins with the 21. It goes up to 16, but P is 7. It goes up to 7. So that is a prime number. This prime number is a long prime number, begins with the 21, it ends with the 7. So when we say mod P, the number that has been written, the one you're seeing on the left, that is multiplied by A. You're seeing there's a number here, then main dot A. Just point what I'm saying, highlight what I'm saying, John. From 21, it goes up to 16 there, then dot 8 means times A. This number is -1 when you do it normal, because you see the number, this number is what John has P, mod P. The P is what John has highlighted, but the last digit is supposed to be 7. So -1 of that would be that number ending with 16. I think you understand what I mean. It's like you have 7, then what has been written there is 6. So 6 times A, it means -1 times A, because if P is 7, and you have 6 times A, 6 times A is the same as -1 times A. Then there's a multiplication sign between, then main B. So just saying -1 times A, then times B, then there is minus the same number, then main times out. Times out is equals to 0. So what that means, let me just write it in the chat. Let me write in the chat what that means so that Joan continues sharing. I've said the first number is like -1 times A, then multiplied by B, and then minus that -1. I'm just writing it. I'll just share. Then multiplied by -1 again. This time multiplied by the output, and we say is equals to 0. We say it's equals to 0. So this is what that number means. It's -1 multiplied by A, multiplied by B, then minus, again minus, then multiply. So what you see, these two minuses, when you multiply them, you get positive. So that means -1 AB plus Z, or plus 1Z, is equals to 0. So when you take the one with the negative on the other side, what you then arrive at is AB is equals to Z. AB is equals to Z, and that is what we began with. That's what we began. So it has just written what we had in the form of rank 1 constraint system. And I've just tried to show you that this is what we began with. We began with AB is equals to Z, and that is what it has printed out. That's what it has printed out, only that this time our mod is a very big number, ending with 7. So the -1 of that is what we then see, multiplied by A, then times, multiplied by B, times B, then minus, again, that number, mod P would be what we are seeing, then multiplied by the output. Now, so these are the rank 1 constraint format of the equation that Joan just typed. What you can see, Joan typed there something called a template, multiply, signal input is A, signal input is B, and then the signal output is, signal output, and then it says we want the output to be as a result of A multiplied by B. Then when she now wants to see the rank 1 constraint system of that, it's converted, and that is what we now see. Okay. Now, so after that, then you will want to maybe now generate a witness and so on. And so I think the concept of generating a witness and so on, we can look at that in the next class. so that we just check to see whether our friends are also with us before we end the class. But those are the steps. So we have come up to there where we are generating the rank 1 constant system. And then
I think we lost him.